Question 6 on paper 2, it's a binomial distribution question. It doesn't say that it's a binomial distribution question, we've got to figure that out ourselves. So let's have a read. A satellite relies on solar cells for its power and will operate provided that at least one cell is working. Cells fail independently of each other and the probability that an individual cell fails within 1 year is 0.8. For a satellite with 10 solar cells, so there's the key. We've got 10 things happening and the probability of each failing is 0.8. So that's the clue that it is definitely a binomial distribution. So we can write our probability distribution here. X is distributed binomial. We say NP, so N is 10 and P is 0.8. Okay. The first part of the question says more than 6 cells fail. So that is the probability that X is more than 6, like that. More than 6 when you've got 10 of something means 7, 8, 9 or 10. So X is greater or equal to 7 would be the same thing. We then just use our calculator to work out that probability. You can do it in the main part, but I like to do it in statistics, as in statistics it tells you, it guides you, it tells you what is your lower, what is the upper, it tells you which order to put things in. So you go into statistics, then distribution, binomial, and you've got 3 options. Okay, inverse B is for an inverse binomial distribution where you've got the probability and you want to work backwards. BCD, that's cumulative, so that's going to add it up. It's going to work out what the probability of 7 is, 8 is, 9 is, and 10, and add it up for you. So that's what we want, as opposed to BPD, which is just going to tell you the probability that it equals a particular score. Okay, so if we put 6 in, it would just say what is the probability that it equals 6, not that it's more than 6. So we're going to press BCD. We're going to say that our lower is 7, our upper is 10, and it will then add those ones up. The number of trials is 10 and the probability P is 0.8. And it will give us our answer, which is 0.8791. We want to write that down to 4 decimal places, at least 3. I'm going to go with 4. Okay. Moving on to part 2 of the question. Part 2 is asking for the probability that the satellite is still operating. Now we know it will still operate as long as it has 1 cell. So therefore, as long as 9 or less have failed, it will be okay. So we go BCD on our calculator, lower 0, upper 9, and then it will give us the answer, which is 0.8926. Okay, if you don't have the new model of the calculator, you would have been fine there for part 2 of the question, but for part 1, when we wanted it to be greater than 7, your calculator doesn't give you a lower and an upper option. It just gives you X, and X is always the upper boundary, so it will always work out from 0 to X. So to work out the probability that it's greater than 7 on the older models, you would need to do the probability that it was X was less than or equal to 6 and then do 1 minus that. So you would need to put 6 in as your X value, which is your upper value, and that would give you the answer for it between 0 and 6, and then you would do 1 minus it and you would get the same answer here. Moving on to part B of the question then. So with part B, it says, for a satellite with 10 solar cells, it is known that 4 of the cells have failed before the end of the year. Determine the probability that no more than 7 will fail before the end of the year. So that's a given. So we're going to do A given B. That's the formula we're going to use. The numerator has the intersection on the top, and the denominator has the bit of information that was given to us. So in this case, the bit of information that was given is that 4 have already failed. So it is known that at least 4 will have failed by the end of the year. So that's X greater or equal to 4 is our denominator. On the top, we therefore know that more than 4 need to have failed, but we want it to be less than or equal to 7. Okay, we work out the denominator using BCD, we put the upper in, the lower in as 4 and the upper in as 10, and that will give us 0.9991. And then for the numerator, we put the lower in as 4 and the upper in as 7, and that gives me 0.3213. With the older model of the calculator, getting that 0.3213 is going to be a little bit tricky. You're going to have to work out the probability of x less than or equal to 7 by putting in 7 as your upper, as your x value, and then you're going to need to subtract the probability that x is less than or equal to 3. Okay, and then that will just leave you with between 4 and 7, and you'll get the 0.321. We don't want to leave that as a fraction with decimals in. Mathematically, that's incorrect. So we'll do the division, and we get 0.3216 as our final answer. Okay. Okay, part C of the question is a little bit tricky. It says, for a satellite with n solar cells, find the smallest number of solar cells that is required so that the probability of the satellite still operating at the end of 1 year is at least 0.095. You've seen questions like this before. So what we do is we go, well, the only way that it's not going to be working is if we have all n fail. Okay, so if x is equal to all n. Okay, so what we've got here is a binomial distribution with n 0.8. So it's no longer 10 anymore, we've got n cells. And if all of them fail, then it won't work. So it still will work if we do the complement of that, if we subtract it from 1. So that's now the probability that it will work, as long as one cell is working. Okay, that's got to be greater or equal to 0.95. Okay, so rearranging that, we'll bring the probability of x equal to n over to this side of the inequality, and we'll subtract the 0.95 from the other side. So 1 minus 0.95 gives me 0.05. So we've got that now. Now the right hand side, the probability that x equals n, we can use that binomial formula, which is n choose n, the probability of a success, or that it fails in this case, 0.8. That's happening n times because all n, and then 0.2 is the probability that it doesn't fail, but that would be to the power of 0 because none of them are going to not fail. Okay, so we've got that, and what we know from that, n choose n, well that's just going to equal 1, and 0.2 to the power of 0, that's going to equal 1. So we've got 0.05 is greater or equal to 0.8 to the power of n. And you can just use your calculator at this case to solve for what n is. You'd probably put an equal sign in rather than an inequality. And it'll be fairly obvious that n needs to be greater than that number. Because of the wording in the question, it says find the smallest number of n. So it's going to be n. That would be the smallest value of n. But doing it the long way, if you like, what we'll do is we'll take logs of both sides. So I'm going to take natural logs. 0.05 is greater or equal to natural log of 0.8 to the power of n, but I can bring the power down to there. So then I'm going to have n, and I'm going to have the natural log here, and I'm going to divide by the natural log of 0.8. Now the natural log of 0.8 is actually a negative, and when you divide by a negative you need to switch the inequality around. Okay, technically that's what we should be doing, and we do that division and it tells me 13.43. Okay, so n is greater than 13.43. If you just left it as an equal sign without an inequality, you would have got n is equal to 14.43, and therefore you would have said n needs to be greater or equal to 14, or the smallest value. It just says what is the smallest value of n. So n, really the smallest value is that n is equal to 14 is our final answer. Now, could you have done that without setting up an equation? Possibly, if you'd have just done trial and error and tried n being 13 and 14, or you might have started smaller, you might have got lucky. And if you'd written down with reasoning that when n was 13, the probability was 0.94, and when n was 14, the probability became 0.96, And if you used your words properly enough, you could have still gained full marks in this question. Okay, so you can see in the solutions that you've been given as well that there are two methods, and you could have got full marks without having to set up this big long formal equation. Okay, so that's the end of question 6.